So dear students, today we will derive Bernoulli's equation by Eulerian equations of motion. So Bernoulli's equations by Euler's equations of motion. So if you remember Euler's equations of motion, which were derived from Navier-Stokes equations of motion, these were delta u delta t plus u delta x, v delta u delta y, w delta u delta z is equal to minus 1 by rho delta p delta x plus fx, where fx is body force in the direction of x. Similarly for y direction, now when we derive Bernoulli's equation, we take assumption number 1, flow is irrotational, and the second one is that external forces are conservative. Now you know that if the flow is irrotational, this implies there exists a velocity potential function say phi, such that q is equal to minus delta phi. There is one more implication from the flow to be rotational, that curl of q is equal to 0, which implies you will get 3 components from curl of q. One component will give you delta u delta y is equal to delta v delta x, because you will get delta u delta y minus delta v delta x is equal to 0. So you will get this relation. Then second one is delta v delta z is equal to delta w delta y, and third one will be delta w delta x is equal to delta u delta z, because the 3 components xi, eta and zeta will be 0. Now similarly, if the forces are conservative, external forces are conservative, then there will exist a force potential function. Say we take v, such that f is equal to minus delta v. Again it implies that we will get fx is equal to minus delta v delta x, fy is equal to minus delta v delta y, and fz is equal to minus delta v delta z. Now we will use these relations, 5th relation, 6th relation and 4th relation in the 3 equations. Equation 1 may be written as Here you have delta u delta t. So in place of u, you will put delta phi delta x. So I may write it as minus delta 2 phi delta t delta x plus u delta u delta x. What we will do in this v delta u delta y, we will use this relation and we write v delta v delta x. Similarly in this w, I will write delta u delta z. In place of delta u delta z, I will write delta w delta x is equal to minus 1 by rho delta p delta x, and in place of this fx, I will write minus delta v delta x. Now symmetrically, I would try to write other equations. Equation 2 will imply minus delta 2 phi delta t delta y. It will be u delta y v delta y w delta y minus 1 upon rho delta p delta y and minus delta v delta y. This I got after substituting these relations 4, 5 and 6. Similarly, equation 3 will become minus delta 2 phi delta t delta z plus u delta z plus v delta z plus w delta z minus 1 upon rho delta p delta z minus delta w delta, this is delta v delta z. Now what I'll do, I will multiply this 7 by dx, this 8 by dy and this by dz, and I'll add all these. So when I'll add these three terms, I'll take delta t outside and inside the bracket delta phi delta x dx plus delta phi delta y dy plus delta phi delta z dz. So I may write minus delta x delta phi delta t dx delta y dy delta z delta phi delta t dz. Similarly, in next term, I will have u as common and there will be delta u delta x dx delta u delta y dy delta u delta z dz, and likewise I will write for v and w, v delta x dx delta v delta y dy delta v delta z dz plus w delta x dx w y dy w z dz on right hand side. Minus 1 by rho will be common and we will have delta p delta x dx delta p delta y dy delta p delta z dz minus delta v delta x dx, delta v delta y dy, delta v delta z dz. Now combining these three terms, I may write minus d of delta phi delta t. Similarly, I may write u. This u may be combined with this, and I may write it as delta delta x of half u square. So I may write it as d of u square by 2, this one, and next one will be v square by 2, and third one will be w square by 2 minus 1 by rho, and similarly this will be dp, and this will be dv, right? Or minus d delta phi delta t plus d of, I may write it as q square by 2 plus 1 by rho dp plus dv is equal to 0. Now I will integrate it along a path. So integrate, suppose it is equation A, integrate along a path assuming t to be constant. So integrating this will be minus delta phi delta t, this will be q square by 2 integral dp by rho plus v is equal to some constant of integration, and because we have assumed t to be constant and this path is independent of time, I may assume it to be ft. This is known as most general form of Bernoulli's equation. Okay. Now we may have certain cases, like case 1. Let the fluid be homogeneous. And or inelastic. This simply means that rho is equal to constant, then B implies minus delta phi delta t q square by 2 plus, now what will happen with this? Rho will come in outside and this will be p by rho plus v is equal to ft. This is a form of Bernoulli's equation of motion. Now I take another case when I assume that case 2. In case 2 I assume that flow is steady. Now naturally when the flow is steady, its properties are not depending upon time. So delta phi delta t will be 0, and in that case C will imply q square by 2 plus p by rho. It will be minus p by rho plus v is equal to, but in this case this is not ft because now your properties are not depending upon time. So we will not write ft, rather we will write c, which is a pure constant. Now when we are deriving this form, because we have derived it with the help of C, so we are also assuming that fluid is incompressible, homogeneous. Homogeneous as well. So these are certain forms in which this term will represent the kinetic energy, this will represent the pressure energy, and this is the force potential. So it is representing the potential energy. Now we come to Bernoulli's theorem. It was Bernoulli's equation derived with the help of Euler equation of motion. Now we find what is Bernoulli's theorem. In deriving Bernoulli's theorem, we take certain assumptions. Number one, flow is steady, as Bernoulli's principle is true for steady flow. Second, no velocity potential exists. So you see the difference between the Bernoulli's equation and Bernoulli's theorem. In Bernoulli's equation, your flow was irrotational and velocity potentials were existing. Here, no velocity potential will exist. And the third one is that forces are conservative. Then the theorem says sum of all the mechanical energies along a streamline are 0. Is 0. Now see, in mathematical form we may write q square by 2 plus v plus dp by rho is equal to constant. Where what is v? V is force potential. Function. So to derive it, we will consider a stream tube. Suppose this is a stream tube. At this cross section A, a stream travel and reaches to B. Suppose A is its cross sectional area and B is its cross sectional area. At A, P is the pressure, delta S is the element of this stream tube. It is going up to this. Suppose G is the gravitational force and let it be H. Approximately, if I take this angle to be alpha, then this is the same as this angle. This is alpha and this is also alpha. Now AB is a streamline. And delta S is small element of it along the axis. Now consider a cross-sectional area. Alpha. This alpha is different from this alpha, so you may take some other notation for it. Cross-sectional area, say beta. Now Newton's law says that rate of change of momentum is equal to total forces applied. You know that in rate of change of momentum, there is the entry of momentum, there is exit of momentum, there is increase of momentum within the volume, and the contribution of all this has been explained you earlier, which gave you density, cross-sectional area, delta S, so that you can get the volume, and dq dt. This is the rate of change of momentum. So left hand side will be this much. What is rho beta delta S? Beta is the cross-sectional area, delta is the small axial length. So beta into delta S will be the volume, and when it is multiplied by rho, it will convert to mass and dq dt. So mass into dq dt will give you total rate of change of momentum. Now come to forces. Forces will be forces. Forces are body force plus surface force. Suppose I take F to be the body force per unit volume. So for the whole volume it will be F rho beta delta S. Again beta delta S will be the volume, multiplied by rho it will be the mass, and F multiplied with mass will be the total body force plus. Now what is the surface force here? The surface force is pressure force. Here it is P, and at this cross section it will be P plus delta P delta S ds. So we have P delta S on this cross section and P plus delta P delta S ds. Further it will be P, this will be P alpha. Alpha is the cross-sectional area and pressure works on surface, so P alpha. And this will be P delta S into, I have taken it beta. P beta. This is P beta. Now what about the symbol? This pressure is working in inward direction and this is working in again in inward direction, but both are in opposite directions. So if I have taken it plus, it will be minus. Finally it is F rho beta delta S plus this P beta will be cancelled with this P beta, and we are left with minus delta P delta S ds beta. So this is the right hand side. So from Newton's law of motion, rho beta dq dt delta S is equal to F rho beta delta S minus delta P delta S ds beta, or beta is common throughout, delta S is common throughout, rho dq dt F beta minus delta P delta S, रो आएगा यहाँ पर, और राइट इट एज दिस इज रो से मैं अभी इसे डिवाइड कर दूंगी, डेल्टा क्यू डेल्टा टी प्लस क्यू डॉट डेल्टा क्यू डेल्टा एस इज इक्वल टू, रो से मैंने डिवाइड कर दिया है तो एफ बीटा, ओ सॉरी बीटा तो कॉमन आ चुका था, एफ देन माइनस 1 upon rho delta P delta S. Now I take flow to be steady. For steady flow, delta Q delta T will be 0, and third implies, ये तो 0 हो गया, इन दोनों को मैं कंबाइन करके लिख सकती हूँ डेल्टा डेल्टा S Q स्क्वायर बाई 2. इसी तरह इस F को मैं लिख सकती हूँ डेल्टा V डेल्टा S माइनस 1 बाई रो डेल्टा P डेल्टा S. Now integrating, about the streamline. I'll get Q square by 2 plus V plus dP by rho is equal to constant of integration. Now again we may take the case 1, if fluid is homogeneous, rho is equal to constant. So equation A will become Q square by 2 plus V plus P by rho is equal to C. Now in this case I will take one more case, that if V is representing the forces, V is representing the surface body forces. So if I take body forces to be gravitational forces, यानी F is equal to minus G cos alpha. You may see in the figure. You may see in this figure that this is G cos alpha, body force. And what is cos alpha? This cos alpha is minus G dH ds, which I can write as delta H delta S, or delta delta S G of H. Now what is this F? This is minus delta V delta S delta S of GH. So this implies V is equal to GH. So substitute it in B. So B gives Q square by 2 plus V, this will be GH plus P by rho is equal to C. This is known as Bernoulli's equation. At times it is written as rho 1 by 2 Q square plus rho GH plus P is equal to rho C is equal to some other constant C1. Here this gives you kinetic energy, this gives you pressure energy, and this gives you potential energy, and the sum of the three energies is constant. So it is the Bernoulli's equation in its standard form under the conditions written in the Bernoulli's theorem. So it is all for this lecture.